Alright, so if anybody's curious, I just wanted to kind of show what's inside of these generic 5 1/4 inch LED headlights that you see all over the place, anywhere from 20 bucks to 100 bucks, even on Amazon. Kind of ridiculous. All really the same thing. So this one comes with 4 groups of LEDs. You have these 2 that run on your low beam. I think they're kind of more for DRL. Then you have the actual low beam and then the high beam up here, both which go through these optical lenses. So basically what I found out about the board is when you supply 12 volts on the board, and my whole point of kind of playing with this was to see how these LEDs are wired. I think I'm going to isolate them and kind of sequence them. So basically how they're set up is when you supply ground and power to the middle one, so that's your amber, and power on this other pin, that's your white. So let's look at the amber first. They're pretty much both the same anyway. So you can see at about 12 volts you have 150 milliamps going through the LEDs, and I think how that's happening is there's a current limiter on the board here at 150 milliamps, because if you check the actual voltage, so let's check the voltage coming out of this board to the LED halo. Alright, so checking the voltage coming out of the board, so we're putting 12.8 volts in, and coming out of the board into the array of LEDs, we're looking at 2.9. So 2.9 volts. That tells me that we're looking at parallel wired LEDs here, and they're all getting 2.9 volts. So they're individually wired on the board here, not in series but in parallel. We do the same thing to the white chips. .85. So again, about 2.9 volts, between 2.8 and 2.9 volts. If we check the voltage of an individual chip, you can see the same thing, 2.7. They should all be about the same. Come on. 2.7. So none of these are in series. They are all in parallel. And we can further conclude that if we put the meter in between and have the load go through our meter, they should all die out. And they do. We can also kind of prove this the reverse way by kind of bypassing the whole board here with the constant current regulation and basically what's driving these LEDs, and let's just put 2.8 volts right to this board. Alright, so we have a ground, we have a shared power, we have an individual ground. So there's 2.8 volts, and these are actually glowing about twice as bright. It's actually pulling 310 milliamps right now, because again, the driver board seems to have a 150 milliamp constant current regulator on it. Do the same thing for the white, pulling even more, almost 400 milliamps. Not really sure what the specs of these chips are. I'm sure they can't run that high constantly, or else the manufacturer probably would have had them running brighter, obviously, instead of the 150 milliamp limit. Alright, now let's check and see what these bad boys are running at, which are your main low and high beams. Don't want to run for too long though, because they are cooled by the whole housing of this headlamp. This whole thing's metal of some sort, so whole thing's a freaking heatsink. In fact, when I was opening the housing with the heat gun, it was getting way too hot to even hold with my gloves on. It was absorbing so much of that heat. Alright, so if we ground that, and this is our low beam, freaking bright. So that pulls, that's pulling almost 2 amps at 12.8 volts. And yeah, they get pretty warm pretty quickly. And again, that's all optically, you know, driven by these acrylic pieces. In fact, we could probably put a 30-degree lens on and see what that does. Yeah, that really, you probably can't see on the camera. You kind of can. The one here with the lens on is a lot brighter and a lot wider of an angle than just the raw chips. So why don't we power them on and then actually see what kind of voltage they're getting, to see if this is also stepping down the 12 volts in some constant current fashion, which I'm assuming it probably is. I don't know if any of these resistors are responsible for that, but I'm assuming not. I'm assuming there's actually some sort of buck step down constant current regulator on the board. It'll be hard to actually hit the contacts. I can't freaking see. It'll probably help if I'm not on amps. Let's kill that for a second. Let's try that again. .1 volts it looked like? 3.1 volts. Each chip looks to be getting 3.1 volts. Come on, there we go. Okay, it's probably going to be the same for the top two as well. So at 3.1 volts, I'm assuming they're both paralleled as well and not in series. So yeah, if anything, I might buy a few more of these just because for, you know, 20 freaking bucks I have a few spare 5 1/4 inch headlamps, and basically you get this halo and this here that can basically be used as a LED driver for free. And these chips on the board look pretty similar to these Rebel chips I got. Sorry, these are the Rebel Stars. They look pretty similar to, and these chips on the board look pretty similar to these Cree XMLs I have here, which also are crazy bright, pull a lot of amperage. And I'll show you that here. So it's freaking ridiculous. It's 2.5 amps. And then the red one even. And then the red one's even more crazy. It's pulling 3 amps. If we put a lens on it, it even amplifies the effect. This is a 120-degree lens. See if I can get it to stay on. Just sitting there. And then you have these Rebel Star chips. They run a good bit lower power than what I just showed the Cree XMLs. These run, I think, like 700 milliamp. But they're still freaking bright for the size of the chip that they are. I mean, that is tiny. I'll kind of do a quick demo here. Totally different color temperature than the last one. This almost looks kind of pinkish. Still crazy stuff.